Hello everyone, welcome back to another class of our basic Python course for numerical analysis. So let me begin. So today's class is the class number 3. During today's class, I plan to cover some small section of modules. It is, I mean, by any means, I don't mean it's small. What I do today will be a little small because I just want to bring an introduction to the modules, how to use modules, and then we will do the introduction to data structures. Okay, let's begin. First, we will begin with modules. Modules can be used to reuse functions in other programs. Python standard library covers number of modules. Okay. First, we will see some example. Can we calculate a square root of a number using some known methods? Example, I want to print square root of 4. So how do I do that? With the known method, we raise 4 is raised to the power 0.5. That is another way of expressing the square root, right? Here, square root of 4 is equal to 0.5. We will see the answer here. It has to be 2. That's okay. And then we can use modules. This module means someone else has made a library, and he or she has defined functions in that library, and we can use those functions he or she has made in our case, in our projects, or in our commands. So first we need to import the library he or she has made. Then we can use the functions from that imported module or library, whatever you want to call it. So now, just a moment ago, I found the square root of 4 using this exponentiation operator, the power operator. This time I will use the math module to do that. Square root of a number using math module. Root of Okay. First as I said, first we need to import the module. Import math. So we are importing the math module that has been created beforehand by someone else. So there are functions in that library. We can use them. Okay. Then you can print square root of that. Math. First we write the name of the module, then dot, then we write the function name. Function name is square root, is QRT, square root of 4. We are using the square root of function inside the math module. Okay. It is 2. So that is how you use modules. There are different types of modules, let's say statistics or anything, and there are functions defined for them. And you can use them after importing the required module. Okay. Okay. Let's try to find sine 30. Sine 30 degrees. So we import math. Now that we have already imported math module, we don't have to import it again, but I just did it for the completion of the note. Now print math dot and what function am I using? Sine function inside the math module, sine. So if I type 30 here, will it give me the right answer? Okay, no. Why didn't? So we know that sine 30 degrees is equal to 1/2 equals to 0.5. But this has given me negative 0.98 something. So here, this only recognizes the angle in radians. So this has taken the radian 30. We need to turn 30 into radians. Degrees 30 into radian. So we use the radian function inside the math module. So we write math dot radian, math dot radian 30. Now here we turn the 30 degrees into radians using the radian function inside the math module, and using this radian value, we calculate the sine value using the sine function of math module. So now it has to give us, where did I go wrong? Radians. Okay, there is no such function as radian. It is radians. Okay. Now still it is not 0.5. It is 0.4999 something. There's a numerical error. So almost 0.5, but not the 0.5 exactly. So what is the reason for this? The reason is this how how does the computer calculate sine 30 or sine any angle? It uses the Taylor series or Maclaurin series for that. So using the Taylor series or Maclaurin series, you approximate the solution by truncating. If you know mathematics, we truncate the Taylor series or Maclaurin series at some point, and because of that, the truncation error and the round off error, we get this value, not 0.5 exactly. So I will teach you those numerical analysis course after this Python course. I am planning to do 7 total videos on Python. After doing the Python videos, 7 Python videos, I will start doing the theory of numerical analysis. And then you can start using the Python for the examples of the numerical analysis course that I will be doing after this Python course. That is why I first started from this teaching Python, and then I can move on to teaching numerical analysis. So that you can work out examples. Okay. Then we can go to data structures. Python has 4 built-in data structures. Okay. What are they? List, tuple, sets, and dictionary. List, tuple, dictionary, and set. Dictionary and set. So these are the data structures in Python. Okay. So we'll begin with list. A list holds an ordered collection of items. A list holds an ordered collection of items. Okay, I'll tell you what it means by an example. So we'll take an example. Create a list with a set of numbers. Okay, let's say number list equals 11 to 23, whatever numbers. 11 to 23, 45, another number 15 maybe. Okay. Okay, we can run this to save the number list. Okay. Now we can print the number list. Okay. Now we see that the number list is has some numbers, some items inside it, inside the square brackets. The numbers are ordered. Like you cannot change the order. Like you can change whatever, but there's an order to that. When we print number list, when we regenerate it or replicate, regenerate it, the order doesn't change. So the order remains as it is. So order is the keyword in lists. Okay, that is fine. Shall I clear these drawings? Fine. Because I want to draw something else. Here I have a list. Level 2, 23, 45, 15. Let's say I want to access a number in this list. Now that it is ordered, we can number the order. Like we can index the numbers. What are the indices we can give? Mm, 0. The first number is given 0, the second number is given 1, the third number is given 2, and so on and so forth. 3, 4. So here we give this index to the first one, give this index to the second number. Why do we do that? Okay, I'll tell you why. So now let's say we want to access a number. We want to access the number at the place of third index. What is that number? It is 45. We need to access a number at the place of second index, but it is 23. Second index is 2. It's like index number 2 is this one, and the value corresponding to that is 23. Okay, that's all. Let's see number list. What is the number at 0th index? It is 11. Number list 4. It is 15. So we will see if that works. Print number list, let's say 2. We are accessing the entry of the in the number list entry at the index 2. What is the entry at the index 2? It is 23. So this should print 23. Okay. These are called, this is the index or indices. This is number list. Okay. Next work. Print each item in the list. For I in number list. Now that we know the for loop, the control flow structure for I in number list, we leave 4 spaces, 2, 3, 4. Then we write the next line that comes under the for loop. Print I. So for I in number list, that means for all the indices in the number list, that means 0, 1, 2, 3, 4, print I. Like for I in number list, first it takes, first we will try to run this. Okay, this just means that for I in number list, for all the indices, this says print I. Okay, that's fine. So I will take the 0th line. I will be at first I will be 11, which is at the 0th index. Second, next, so it will print 11. Next, I will be 2. I will take the value at the next index, which is 2. It will print. In the next iteration, I will take the value at the second index, which is 23. So it will print that. It will print until until it prints all the indices, not the indices, the values at all the indices. Okay. Next one. Add a number to the end of the list. Let's say add 29 to the end of the list. Number list dot append which value? 29. Print number list. Okay, earlier our number list was this one. The last number was 15. Now it has appended 29 to the end of the list. Yes, 29 after 15. Okay. Next, insert an item in between index, let's say 2 and 3. Number list insert. Let's say 3, 55. What does this mean? So we know that at index 3, the number is 45 here. What we are doing here is we are inserting 55 at the index 3. We are inserting 55 here. Then 45 and 15 together. Together they shift one step to the right side, right direction. So we can print number list now to see what has happened. Okay, earlier this was the case. Now at the index, this is 0th index, 1, 2. At the third index, it has inserted 55. And 45, 15, 29 have shifted one step to the right direction, to the right side. Okay. When we insert something, all the rest of the things at the right side move one step rightwards. Okay. Delete the first item. Can you do that? Delete number list. The first index of the first item is 0. So we delete 11. We delete 11 here. Then the remaining number list should be this one. Okay, we can delete this and we can print the number list. Yeah, we can see the 11 is deleted. Something has gone wrong. What happened to two? I executed the number list twice. So that was the case. Okay, now I run this. The 11 must be deleted now. Yes. Okay, that is fine. Delete the whole thing. Delete the whole. Delete number list. The whole list. Oh, wait. Delete number list and print number list. Now it should give us an error message because how can we print anything that does not exist if it is deleted? Number list. Delete number list. Okay, name number list is not defined because we deleted it. Okay, that's fine. Next topic is it is the nested list. Shopping list. I'll take an example first. Shopping list equals a list can be an empty list as well. There can be no entry in the list. Then shopping list append. you can put things into the list. Okay. List. Yeah, adding an item into the list. Append. Do the append. We want 5 apples. Let's say apple. 5. Print shopping list. Now this is my shopping list that has apple 5 apples, whatever. Okay. Next we append another thing into the list. We want to buy something else. Shopping list dot append. Banana, 10 bananas. Say banana. Print shopping list. Now I have 2 items in this list, apples and bananas. I have 5 apples and 10 bananas. So we can see that unlike the previous case, we have some coupled items. Like apple 5 is like combined together as an entry, and banana 10 is combined together as some one entry. So how do we access an item inside the list? Print shopping list, something inside it. What will this print? Now we can see that if you if you focus on outermost square brackets, what is inside the outermost square bracket? This thing. So we have 2 nested items. So shopping list 0 should print the first item inside the outermost square brackets. This is the first item. This is the second item. Okay, apple 5 should be printed. When we print this, what will it print? First item inside the outermost square bracket, that is apple 5, and first item inside that. That means there are 2 items inside apple 5. Those 2 items are apple and 5. So the first one is apple. Second one is 5. We want to access the first one. Apple. This should print apple. Okay, nice. Then what will this print? First item inside the outermost square brackets, that is apple 5. Then 1 means the second item inside the apple 5, which is 5. This should print 5. Okay. Nested list are used as matrices. Matrices. Let's say they can be used as matrices. Matrix is equal to print matrix. Okay. See, 1, 2, 3 is like, let me write it. In this matrix, let's say we have a matrix 1, 2, 3. These are the entries in the first row. This is the entry of the first row, first column. This is the entry of the first row, second column. This is the entry of the first row, third column. 4, 5, 6, 7, 8, 9. If this is my matrix, what is this one? This is the entry of the second row, third column. So this is my first row, 1, 2, 3, which corresponds to this one. This is my second row, which corresponds to this. This is my third row. Okay. Let's say I want to access the first row. How do I access that? I want to print. In the first row. I want to print matrix. The first row is 0th index. 1, 2, 3. Okay, those are the basics about the list. Then we can go to talking about the next data structure, which is the tuple. A tuple holds an ordered collection of items. However, after creating the tuple, one cannot add, remove, or change items. Okay, tuple is very similar to the list, but unlike the list, once the tuple is created, one cannot change uh, or append or remove anything from that tuple. So on the other hand, in the lists, we changed, we updated, like we appended items, we removed items from the list. Uh, so we cannot do the same with tuple. It is fixed once it's created. Okay. Let's work some example. A tuple with a set of numbers. Let's create it. Number tuple. Number tuple equals 11 to 23. Let's take the same numbers we used under the list. 11 to 23, 45, 15. These are the numbers we used previously. Print number tuple. For this, we use the square brackets, whereas in tuple, we use, what do you call these brackets? I don't know. Some normal brackets, like curve, or like part of a circle. These brackets, normal brackets. Okay. Print number tuple. Let's access an item in the tuple. Let's say print number tuple. I want to access the first item, which is the index 0. It's 11. So I want to access all the items. So I in number tuple 1, 2, 3, 4. Print I. So it will print every number in the number tuple in the order it is written here. 11 to 23, 45, 15. Okay, like that. We can see how many entries are there in the number tuple by using the length function. Print length number tuple. How many numbers are in? 1, 2, 3, 4, 5. So this should print 5. Like I said. Okay. Next, we can do the third type of data structure, which is set. A set holds an unordered collection of unique items, similar to the sets in mathematics. Can you remember the sets in mathematics? So I will do these mathematical concepts, the calculus and set theory and probability, numerical analysis, everything after this series on basic Python. So this is a long time project for all the people who are passionate about mathematics and its application. So a set holds an unordered collection of unique items. Set holds an unordered collection of unique items. Similar to mathematics, sets in mathematics. Let's take an example. Create a set with a set of numbers. Create a set with a set of numbers. Number set. Because let's use the same numbers we used before. However, this time we use similar to sets in mathematics, we use curly brackets. The unique items are lying inside the curly brackets. 11, 2, 23, 45, 15. Now we entered in the same order we used before. Then it will print number set. Okay, although we entered the numbers in the same order we used before, it has printed in a different order. The number set has been printed in a different order. So which means something. For sets, it is not, the order is not important. What's important is if there are unique items, so the type of items or the items cannot change. The same items are there maybe in a different order or same order. Order doesn't matter. Order is not important for sets as long as the items are unique. Okay. Print each item in the set. So I in number set. Print I. Print everything inside the set. Okay. Length of the set. How many numbers or how many entries are there in the set? Print length number set. One, two, three, four, five. Yeah, correct. 5 numbers are there. And an item to the set. And an item. Number set. Add the value. Number set. Dot add What is the number we are adding? Let's say we are adding 6, number 6. We are putting number set inside the set. Print number set. Let's see where the 6 is added. So you see, it is not added necessarily at the end. It can be added anywhere. So it will be added anywhere, not necessarily at the end. Okay. Add multiple items to the set. Number list update. Number set, sorry. Number set dot update. So we see, even though we are adding numbers, we don't say add, we don't use the add function. Add function is used to add only one number or one item, but to add multiple items, we use update function. Update, we add it as some list 6, 7, 8. Okay. Print number set. Print number set. 6, 7, 8 should be there. 6, 7, 8 are added. Okay. Remove an item in the set. Remove an item in the set. Number set, remove number set dot remove. Let's see what numbers are here. We want to remove 45. Number set dot remove 45. Print number set. Okay, we can see 45 and all the other numbers are here. So 45 is removed from the set. Okay. Let's say we try to remove 45 again. But that doesn't make any sense because 45 is not there. Because of that, it doesn't make any sense that we want to remove 45 again from the list. So it should give us an error message because 45 is not inside the set. It doesn't exist. Why did I do that? Say we want to discard an item from the set. Discard an item in the set. Discard an item in the set. Number set dot discard. Discard. Let's say we want to discard number 2. Print number set. Print number set. Now 2 must be gone now. See, we don't see 2 here. But let's say we do it again. we knowing that 2 is not there in the number set anymore, but we want to discard it again. Like, so we are given the same set. So it doesn't give us an error message like in the remove function. In the remove function, when something is not there in the set already, it cannot remove that something, that's some value. On the other hand, on the discard function, in the discard function, it removes or it discards anything, even if that entry is not there in the set already. Here, the 2 is not there, but it doesn't give us any error message. So which one will you use, remove or discard? It depends on depends on the application. If you know some entry is already there in the set, you can use the remove function and to remove that entry. But if you are not sure something, whether something is there in the set, but if there is that entry, you want to discard it. Then you can use the discard function. Okay. Delete the set. Delete the set. Delete number set. Number set. Print number set. Once we delete, it cannot print anything, right? So we delete it. Can we print the number set? It should give us an error message because the number set is already deleted and number set is not defined because it's no longer there. It's gone because we deleted it. Okay, our last data structure, which is dictionary. Oh, dictionary. So let's define a dictionary. Let's say, what do you call one in Japanese? One in Japanese word. I think it's too hard for me. Let's see, there is some language. I have some examples written in my notes. So I'll use the same example. Number dict. We define the dictionary. Number dict. That's a variable. We open the curly bracket. Actually, the number diction, the dictionaries are a form of sets. It has many attributes similar to sets. So dictionaries always have curly brackets. Okay. Let's say we have one. In English, we have one. Let's say in some other language, one is called ichi. In English, we have two, number two. In some other language, the two is called ni, comma. There is number three in English language, and it is called san in some other language. Okay, let's say one. We have three items. One, two, three. We have English language word and the corresponding word from some other language. English language word, other language word. English language word, other language word. Okay. Okay, the dictionary is defined. Print number dict. Print number dictionary. Okay. One ichi, two ni, three san. These one, two, three are called keys. These are keys. And these are values of the dictionary. So we have key and its value, key and its value, key and its value. Okay. So we'll first access keys. Okay. For I in number dict, print I. I in number dictionary, print I. So it should print what? Let's see. So we won't print everything in the number list. I will take the key, the keys, the form of keys. It will print in order. Not in order, I mean, it will print all the keys. One, two, three. Keys are printed. Next is values. For I in numeric values. Numeric dot values. 2, 3, 4. Print I. Print I. Now, when you use the numeric values function, it will print ichi, ni, san, which are the values of 1, 2, 3. How do we access an item? Access an item in the dictionary. Item. Okay, access an item. Let's say we want to access something, number dictionary. Instead of writing the indices or index, we write the key name. In fact, here in dictionaries, the keys are working as the indices. The keys are the indices here. So this is 2. Let's say we want to access the key number 2, the value of the key number 2. We want to print it. So it is ni. right? Here, the key is 2. The value of that is ni. Let's say we want to add an item to the dictionary. Add item. Number it. Let's say we want to add the fourth number, words for the fourth number. The English word is 4. 4. So that fourth key, the value of fourth key is U. Not you and me, I mean, it's the U. Let's say yo. Print number. Now there has to be 4 items. 1 ichi, 2 ni, 3 san, 4 you. So the 4 you part has been added. Okay. We want to replace an item. Let's say replace a value. Number it, let's say number it. Let's say we replace yo word something else. For the key 4, we give a new value here. So 4 key, that is the key, and the value is replaced as, let's say, she, the new name. Print number. See, the E4 has a new value, she, not yo. Let's say we want to delete an item in the list. How do we delete an item? Delete number list. Sorry, number list. Delete number list 2. Print number. Print number list. So you see the 2 ni. 2 ni is not here. 1 ichi, 3 san, 4 she is 4 she are there. The 2 ni part is not here. So it's been deleted. Delete the whole dictionary. Delete number list. Print number. So this code will delete the number list. When you try to print it, it should give us an error message, because how can we print a deleted dictionary? It does not exist. the name numeric is not defined because there is no such thing because we deleted it. So those are the data structures I wanted to introduce today because they will be really helpful in coding when it comes to doing numerical analysis. We use a lot of probability dictionaries, lists, sets, and probability tuples as well. And we use a lot of modules to handle problems. So this is the basic introduction to this. We will be using these things in our next videos a lot. So that's the end of class number 3. In the next class onwards, I will do some other things like vectors, matrices, and in the last video, I will be doing some machine learning example in Python. Okay. So thanks for watching.